So here we're given that the limiting value of the function when x approaches 2 is equals to 80, where n belongs to the set of natural numbers n. So we have to determine the value of n. So let us begin by finding the limit on the left hand side by applying our standard limit value. So it's already in the standard form, which is limit x approaching a, x raised to the power of n minus a raised to the power of n divided by x minus a is simply equals to na raised to the power of n minus 1. So here we have n times 2 raised to the power of n minus 1 equals to 80. Now we're going to find the factors of 80. So we have 2 times 40 is 80. So 40 can be further broken down into 2 times 20, and 2 times 20 will be 2 times 10. So 10 will be 2 times 5. So that means 80 is simply 2 times 4 times 2 raised to the power of 4 times 5. So that means we here have 2n times 2 raised to the power of n minus 1 equals to 5 multiplied to 2 raised to the power of 4. Now what we can do here is we can, instead of writing the power of 2 as 4, we can rewrite it as 5 minus 1. Now when we compare the both sides, we'll find that the value of n is equals to 5. So this is the value of the small n5 for which the given limit exists and has a limiting value of 80. So here we have limit x going to 1, x raised to the power of 4 minus 1 over x minus 1 is equals to the limit x going to k, x cubed minus k cubed divided by x squared minus k squared. So when these two limits are equal, so using that we have to find the value of k. So let us begin by converting our given limit on the left hand side to its to the standard form. So that will be limit x approaching 1. So we have x raised to the power of 4. So 1 can be rewritten as 1 raised to the power of 4 divided by x minus 1, which is equals to limit x approaching k. So what we are going to do, we're going to divide the numerator and the denominator by x minus k. So we have x cubed minus k cubed divided by x minus k divided by x squared minus k squared divided by x minus k. So now we're going to apply our value for the standard limit. So we have 4, which is the value of n, times 1 raised to the power of 4 minus 1, which will be equals to 3 times k raised to the power of 3 minus 1 divided by 2 times k raised to the power of 2 minus 1. So we have 4 on the left hand side, and that will be equal to 3 over 2 times k squared over k. So that gives us 4 is equals to 3 over 2 times k. Now solving for the value of k, so we have 8 over 3. So this is going to be the value of k for which the two limits are equal. So here in this question we are given that when x approaches negative a, the limiting value of the given function is equals to 9. Now we have to determine the value of a. So let us rewrite the function. So we have limit x approaching negative a. We have in the numerator x raised to the power of 9. So what we're going to do, we're going to rewrite it as minus times negative a raised to the power of 9 divided by x minus minus of a. Because we have negative a raised to the power of 9 is equals to negative a raised to the power of 9. So that negative gets multiplied to the minus sign and make it positive. That will become exactly like the original function here. Now that has been done, so this is equals to 2. So that our given limit is now in the standard form. So we have n times I raised to the power of n minus 1, which is equals to 9, which will give us 9 times negative a raised to the power of 8, which is equals to 9, which is equals to 9 times, so negative a raised to the power of 8, 8 being an even number, so we'll get a positive number here, which is equals to 9. So that gives us the value of a raised to the power 8 equals to 1. So solving for a, so we can have two values, one is positive 1 and negative 1. So here in this question we have, when x approaches a, the limiting value of the function given on the left hand side is equals to the limiting value of 4 plus x when x approaches 5. So using this information we need to determine the value of a here. So let us begin from the left hand side. So we already have the given function in the standard form, so this the particular limit is going to give us 9 times a raised to the power of 9 minus 1, which is equals to simply the limit x approaching. So we can straight away substitute for the value of x. So this was going to give us 4 plus 5, which will be equals to 9 times a raised to the power of 8 equals to 9. So this is similar to the previous one. So we have a raised to the power of 8 equals to 1. So that gives us two values for a, so which will be negative 1 and positive 1.